All right, we're going to look at three examples for drawing dot diagrams for ionic, polar covalent, nonpolar covalent molecules. And you can use this as review or if you were gone the day that we did this in class. So let's take a look at the first one here. We've got a metal and a non-metal. So the key thing to remember when you have a metal and a non-metal is it's always going to be ionic. Metals want to give away electrons to non-metals. And when they give away electrons, they become ions. When a non-metal receives electrons, it becomes an ion as well. Positive ones are called cations, remember. Negative ions are called anions. So the first thing we need to do in this case is we need to draw a dot diagram for each of these two elements. Sodium is in group 1, so it has one dot. Nitrogen is in group 15, so it has 5 dots. And I think it's helpful to draw in on the non-metal little boxes representing where it would like to get electrons to complete and fill that shell. So you can see sodium or nitrogen has 3 electrons it would like to get. And this sodium is more than willing to give 1 away to it. But the problem is nitrogen needs 2 more. So therefore what we do is we need 2 more sodiums. So we would draw 2 more sodiums, and each one of those has 1 dot. And what I have down here is, just remember that we have reactants and products. The reactants are the things that we start with, so they're on the left side of the arrow, and then the products are what we end up with on the right side of the arrow. So we start out with 3 sodium are going to react with 1 nitrogen. And when they do, each of the 3 sodium now, because this is ionic, they turn into ions. Each of those 3 sodiums becomes charged 1 plus. Each one of them becomes a cation with a 1 plus charge. And the one nitrogen, what it did is it gained 3 electrons, one from each of the sodium, and it became charged 3 minus because it's gaining negative electrons. So that's how we show that this is ionic, because this is how we write ions, an element with a positive or negative charge. So that's how I would draw this. The reactant's mass has to equal the product's mass. That's the law of conservation of mass. So in other words, if I've got 1, 2, 3 sodiums on the left side of the equation, I need to have 1, 2, 3 sodiums on the right side of the equation. And if I've got 1 nitrogen on the left side, I need 1 nitrogen on the right side. So those numbers have to match up because the masses have to match up, and that's what the law of conservation of mass says. So this would be how you would start out with 1 sodium and 1 nitrogen, figure out that you need to add 2 more sodiums, and then show what you have over here as a product when you're all done. So this one is an ionic compound, and you can see we have ions. When we have ions, we don't have dots around things. When we have ions, we don't have those dots because they are either gained or lost to fill that shell and become charged as an ion. Let's look at another example. Now this one is similar in that we've got 5 around the nitrogen wanting to gain 3. And it's similar that we have 1 electron in the outer energy level of hydrogen. But this is very, very different because hydrogen can never give its 1 electron away. Remember, nonmetals are never going to give electrons away. Nonmetals will receive electrons, or nonmetals will share electrons. So hydrogen can't give it away, so these are going to share. And once we know it can't give away, we know it can't be ionic. Sharing is covalent, so we know it's either polar or nonpolar covalent, which we'll figure out after we finish our drawing. So we take a look here, and this hydrogen could move right over here and kind of fit in there and share, okay? But the problem is nitrogen needs two more hydrogens as well to share with it. So if I draw two more hydrogens in there, and now my reactants are 3 hydrogen and 1 nitrogen. So now I show what they produce, what the products are. And again, this is going to be sharing, so I'm going to put a hydrogen, and then I'm going to put a nitrogen pretty close to it, and then I'm going to put another hydrogen at a 90-degree angle, and my third hydrogen at a 90-degree angle, and then I'm going to show how they share. Each hydrogen says, I'll share one. The nitrogen says, I'll share one with this hydrogen, I'll share one with this hydrogen, I'll share one with this hydrogen, and then the nitrogen had 5. So these, if you want to think about it, are the ones that were being shared over here. And therefore, we have the 2 extras that are up there that we put there. So now if we take a look at what we have electron-wise, okay, this hydrogen, remember, whatever's in between them, they get a share. So this hydrogen gets those 2 only. It has 2. This hydrogen has 2, but remember, it only has 1 shell, and that outer shell is full with 2 electrons. So each one of these hydrogens are stable and full with 2 electrons. So each one of the hydrogen has 2 electrons, and now if I take a look, the nitrogen gets all the ones in between, so it gets these, it gets these, it gets these 2, and then it also has these 2, so that nitrogen has 8. So that's how we decide if it's polar or nonpolar. Because remember, the word polar means opposite ends. So we have a negative end and a positive end to this molecule. We do in this case because we look at the number of electrons, and the nitrogen has 8 electrons around it, where each hydrogen only has 2 electrons around it. So the nitrogen is more negative. So I show that with a negative sign here, and then I show the opposite of that is going to be the positive side of this molecule. So this is then going to be polar covalent. It's going to be polar covalent. Polar, so then I need to show the negative side, and I need to show the positive side. So this would be a polar covalent molecule. And anytime hydrogen is forming a molecule with a different nonmetal, not itself, but it's forming a molecule with nitrogen or oxygen or fluorine or chlorine or sulfur or phosphorus, bromine or iodine, it's going to be polar because that hydrogen is only going to have 2 electrons around it, and that other nonmetal is going to have 8. And that's what's going to make it polar covalent. Now let's take a look at one where we have 2 bromine. And bromine has 7 electrons around it, so 1, 2, 3, 4, 5, 6, and 7. And this other bromine has 7, 1, 2, 3, 4, 5, 6, and 7. So each of the bromine would like to get an electron. But remember, nonmetals, they are willing to have someone give them electrons. They're never willing to give them away. They have a high electronegativity, so they want to keep those electrons. They want to get more brought into them. Since neither one of these are willing to give away electrons, they will share electrons. And we take a look, they both want to get one. Well, if they both want to get one, if they're share one, it will work. So again, if we're talking about sharing, we know we're talking about covalent, it's not ionic. So we put the bromines kind of close together, and we show that this first one says, I'll share one, and I've got my other ones here. If you will share one, and then you've got, it's got its other ones as well. So now we take a look to see whether it's polar or whether it's nonpolar. And this bromine here has 8 electrons around it. This bromine here has 8 electrons around it. So they are the electrons are shared evenly. We don't have opposite ends. We don't have one side that's more negative than the other because they both have 8. They're equally shared. So therefore, it's nonpolar covalent. If it's nonpolar covalent, we don't have a negative side and a positive side. It's done, written just like that. Now, if bromine was forming a compound with a metal, and then that bromine, instead of having one shared with it, if it had one given to it, it would turn into an anion and would be written like this, and it would not have any electrons around it. So when it becomes an ion, it looks like this. In this case, it's sharing. When it's sharing, we don't have this ionic charge, and we do have these dots in here around it. So that's one way of knowing the difference between ionic and covalent. Now this just shows what this looks like with this electron sharing. So if we look over here, at the ionic one, you can see these are the electron clouds, and you can see there's a gap in between here because there's not any electron sharing going on. And this is ionic. When we look at either the polar covalent or the nonpolar covalent, but if we look at the covalent ones, you can see that these electron clouds here are being shared. And if we take a look specifically at nonpolar, nonpolar means it's shared evenly. So you can see these electron clouds here are about the same on both sides. And then if we have a polar one, this electron cloud is bigger than this electron cloud. But they are sharing here in the middle. And those are the electrons that are being shared. And they show this with the bond here, and we've been showing this with two dots that make up that bond. So that just is a visual showing you what you have. And then your assignment, which you had to do, was taking these and drawing them out and showing if they, when you're done, are ionic, polar covalent, or nonpolar covalent. You always start out with one of each. So you're going to start out with one magnesium and one bromine. Let's see, where did I miss one? 7. And then you see if you need to add another bromine or another magnesium. And then you're going to put your arrow, and then you're going to put your products over here. So again, you can go back to look at this if you need more review. But that's one ionic, one polar covalent, and one nonpolar covalent molecule.